Welcome back to G-Fun Facts Online. Today, we are going to completely dismantle the mental image you have of the night sky. When you look up on a clear night, away from city lights, you see stars, maybe the band of the Milky Way, and between them, you see a deep, inky blackness. We have been conditioned to think of that blackness as a void, empty space, a vacuum where nothing exists. For decades, even professional astronomers believed they had a pretty reliable map of what was out there in our immediate galactic neighborhood. We knew the bright stars, the swirling dust lanes, and the stellar nurseries like the Orion Nebula. We thought we knew the layout of the furniture in our room. But in 2025, that confidence was shattered and then rebuilt into something far more wondrous. It turns out, we have been living next door to a Leviathan, a massive structure hiding in plain sight, and we simply didn't have the eyes to see it until now. This is the story of Eos. Let's start with the sheer scale of what we missed. Imagine looking at the full moon. Now, imagine a structure stretching across the sky 40 times wider than that moon. That is the size of the object we are talking about. It is called Eos, named after the Greek goddess of the dawn. It is a colossal cloud of molecular hydrogen, a reservoir of the raw material that stars are made of. It contains enough gas to build 3,400 suns. And perhaps the most unsettling fact of all is its location. In cosmic terms, it is touching our faces. Eos is located just 300 light-years away. To put that in perspective, the famous pillars of creation are 7,000 light-years away. The Orion Nebula is 1,300 light-years away. Eos is mere inches from us on the galactic scale. Yet, until recently, it was completely invisible. It didn't block starlight like a dense dust cloud, and it didn't emit the radio waves astronomers usually hunt for. It was a phantom, a dark reservoir floating at the edge of our own local bubble. Its discovery has not only rewritten the map of the solar neighborhood, but has also pioneered a revolutionary new way to see the universe, by watching the darkness itself begin to glow. To really understand why this discovery is a massive deal, we have to take a step back and look at how astronomy is actually done. We need to talk about the fuel crisis of astronomy. We know that stars are born from collapsing clouds of molecular hydrogen. This simple molecule, H2, is the most abundant substance in the universe. It is the fundamental building block of galaxies. Without it, there are no stars, no planets, and certainly no life. But here is the catch. Molecular hydrogen is notoriously shy. Chemically, it is a symmetric molecule. Two hydrogen atoms bonded together share their electrons equally, which means the molecule doesn't have a dipole moment. In plain English, this means it doesn't easily emit radiation that our telescopes can detect, especially in the cold depths of interstellar space. For all intents and purposes, pure hydrogen gas is silent and invisible. So for half a century, astronomers have had to use a cheat code. They couldn't see the hydrogen, so they looked for its loud, gregarious cousin, carbon monoxide, or CO. Carbon monoxide almost always hangs out in the same clouds as hydrogen, and unlike hydrogen, it sings loudly in radio waves. It's a very bright tracer. So the standard logic went like this. Wherever we see carbon monoxide, we assume there is a lot of hydrogen there. Conversely, and this is the dangerous part, where we don't see carbon monoxide, we assumed the space was empty. But for years, the math simply did not add up. When astronomers calculated the rate of star formation in the Milky Way, there seemed to be more stars forming than the visible carbon monoxide clouds could account for. It was like trying to bake 1,000 loaves of bread when you only have receipts for 10 bags of flour. The flour had to be there, but it wasn't on the books. There was a suspicion that a dark gas existed. Reservoirs of pure hydrogen that lack the carbon monoxide tracer, effectively invisible to our standard maps. Eos is the smoking gun of this dark gas theory. It is a Colorado dark cloud. It is either so chemically pure or so diffuse that carbon monoxide hasn't formed in detectable quantities. It was hiding in the blind spot of modern astronomy. So how do you find something that is invisible to standard radio telescopes? You have to change your eyes. You have to stop listening for the radio hum and start looking for a ghost. This discovery was led by Dr. Blakesley Burkhart of Rutgers University and Dr. Thavisha Dharmawardena of NYU. They realized that while hydrogen doesn't emit radio waves, it does interact with ultraviolet light. When starlight from distant massive stars hits a hydrogen molecule, the molecule absorbs that energy. It gets excited, and then it re-emits that energy as a specific frequency of far-ultraviolet light. This process is called fluorescence. Think of it like a blacklight poster. In a dark room, the poster is invisible, but if you shine a UV blacklight on it, the ink absorbs that energy and glows. The gas cloud is the poster, and the surrounding stars are the blacklight. Ideally, if you had a telescope sensitive enough to far-ultraviolet light, or FUV, you could see these clouds glowing faintly against the black of space. But FUV is notoriously difficult to work with. It is blocked by Earth's atmosphere, so you can't do this from the ground. You need specialized detectors in space. The researchers turned to archival data from a South Korean satellite mission called STSAT-1, which carried a sensitive instrument known as FIMS, the far-ultraviolet imaging spectrograph. They weren't even looking at new data. They were mining old data, looking away from the bright galactic plane where everyone else looks. And there, buried in the noise, they found it. A massive, crescent-shaped structure glowing faintly in the ultraviolet. Dr. Burkhardt noted that the cloud is literally glowing in the dark. It was hiding in plain sight all this time, waiting for us to look with the right eyes. They named it Eos, because in mythology, Eos is the goddess who opens the gates of heaven for the sun to rise. It was a fitting name for a cloud that represents the dawn of a new era in mapping the interstellar medium. Now, let's look at the anatomy of this ghost. Eos is a beast. If your eyes could see in the far ultraviolet spectrum, looking up at the night sky would be a terrifying and majestic experience. Eos would dominate the view, a glowing, diffuse river of gas spanning nearly 40 degrees of the sky, dwarfing the constellations it passes through. We are talking about a structure with a diameter of roughly 80 to 85 light-years. It is comprised almost entirely of molecular hydrogen, with trace amounts of dust, but significantly lacking in carbon monoxide. Its shape is roughly crescent or filamentary, looking like it is draped over some invisible cosmic boundary, and that is exactly what it is doing. Eos sits right at the shell of the local bubble. The solar system currently drifts through a cavity in the interstellar medium called the local bubble. This is a region of hot, low-density gas, likely carved out by ancient supernovae millions of years ago. Imagine a snowplow pushing snow to the side of the road. The supernovae were the plow, and Eos is the pile of snow, the cosmic debris swept up by the expansion of the local bubble. It rides the shockwave, where the bubble's expansion meets the denser resistance of the interstellar medium. But Eos is not just a static monument or a pile of debris. It is a laboratory demonstrating the life cycle of the galaxy. Despite its massive size, containing 3,400 solar masses of gas, Eos is not currently forming stars. It is too diffuse. Gravity has not yet won the battle against the internal pressure of the gas. In fact, Eos is dying. This is the tragic beauty of the discovery. The same ultraviolet light that allows us to see Eos, the radiation from nearby stars, is also slowly destroying it. This process is known as photodissociation. The UV photons strike the hydrogen molecules with enough force to break the chemical bonds holding them together, stripping the cloud apart atom by atom. Based on current models, the team estimates that Eos has only about 6 million years left to live. In cosmic time, this is a blink of an eye. It suggests that these dark clouds are transient, fleeting structures. They form, gather mass, and if they don't collapse into stars quickly enough, they evaporate back into the diffuse haze of the galaxy. This transience explains why we haven't found them easily. We are catching Eos in a brief moment of existence between the atomic fog phase and the stellar nursery phase. It is a missing link in the evolution of matter. The discovery of Eos at such a close distance has unsettling implications for our understanding of the Milky Way. If a cloud as massive as 3,400 suns could hide just 300 light-years away, how many tens of thousands of similar clouds are hiding in the distant reaches of the galaxy? This dark gas could account for a significant portion of the missing mass in the interstellar medium. It solves the discrepancy in star formation rates we talked about earlier. The fuel was there all along, we just couldn't see it because we were looking for the wrong signature. Furthermore, the technique used to find Eos FUV fluorescence is now a proven tool. We have a new way to hunt. Future missions, such as NASA's upcoming ultraviolet surveyors or specialized instruments on the James Webb Space Telescope, can now be calibrated to hunt for these ghosts. We are effectively putting on night vision goggles for the galaxy. Why does this matter to us specifically? Because 300 light-years is effectively our backyard. The proximity means that the solar system interacts with the environment Eos inhabits. While we are not on a collision course with the cloud, its presence at the edge of the local bubble tells us about the violent history of our neighborhood. It stands as a witness to the supernovae that blew the bubble we live in. Moreover, studying Eos allows astronomers to study the physics of star formation at a level of detail never before possible. Because it is so close, we can resolve the delicate filaments and turbulent eddies within the cloud. We can watch the tug-of-war between gravity trying to make stars and radiation trying to destroy the cloud, playing out in high definition. The discovery of the Eos reservoir is a humbling reminder of nature's ability to keep secrets. We look up at the night sky and see a void between the stars, but that void is an illusion of our limited biology. In reality, the space above us is thick with the glowing, swirling, breathing potential of future suns. Eos stands as a silent sentinel at the gates of our solar neighborhood, a vast, invisible giant that has watched over Earth for millions of years, only revealing itself when we finally learned how to look. As we refine our ultraviolet eyes, we can expect the map of the Milky Way to fill up, transforming from a lonely archipelago of stars into a connected, glowing web of matter. We used to think the space between stars was empty. Now we know it is full of ghosts, waiting to be born. Thank you for listening to G Fun Facts Online, and remember to keep looking up, because there is always more than meets the eye.